Today's lesson is Module 1, Topic 1, Lesson 1, Points, Lines, Planes, Rays, and Line Segments. These are the basic building blocks of geometry. So let's go ahead and get started with our definition of a point. A point is written as a dot. It has no dimension, which is length or width, and it is named by a capital letter. So this is the very common way to see a point, and we would simply just name it with the capital letter that's with it. Sometimes you'll see the word point written in front of it, of the capital letter A. However, it is not necessary. We understand worldwide that when we use one letter, we are talking about a point. Our next building block is a line. You saw a lot of these in algebra. However, we're just talking about the shape, the diagram of a line. A line has one dimension, which is length, and extends without end in two directions. In geometry, it is very important that our lines contain arrows at both ends. This is to show that extends without end in two directions. A point can have an infinite amount of points on it. I've placed 3 on there for naming purposes. Through any 2 points, there is going to be exactly one line. And you can use any 2 of the points on that line to name it. So some names for this line would be AB. Now, when we're just going to use the 2 letters, we also need to use the line symbol or the word line. So we agreed a long time ago, us geometry teachers, that a line will look like a straight dash with arrows on both ends. And it's just going to go above the 2 letters. Any 2 letters work, so I could use the first and the last. Sorry about that. The first and the second and the last one. Or I could use the first and the last one. All 3 of these are proper names for this line. I could also go and switch the letters. BA, CB, CA. That's 3 more names for this line, all of which are correct names. All right, let's go ahead and take a look at this mathematical model that has several points and lines shown. So just to draw your attention, we have some points here with our dots, and then we have our lines going like this because we have our arrows. So there's a line, there and there. Okay. Is line C a unique line? Why or why not? Well, let's take a look at line C. They're only giving us 1 point, and they're using the word line. So there's line C. Are they talking about this line C? Or are they talking about that line C? Both of these are line C. So I'm going to have to say no. There are 2 lines that are passing through point C, so this is not a unique name. Is line CD a unique name? So notice they're not using the symbol for line, they're using instead the word in this case. Totally fine. So let's go ahead and find the points C and D because they asked us to find both. Is there only one line that goes through both points C and D? It would have to be this one. It's the only one that connects C to D. So I'm going to go ahead and say yes. There is only one line that passes through both C and D. So unique name. All right, question number 3. How many points are needed to name a specific line? That's right, 2. We only need 2. It doesn't matter how many there are. What is another name for line AB? Let's go back and take a look just to make sure there's not any other points on the line. A, B. The only 2 points on that line are the points A and B. So instead of using the word line, I could change and use the symbol. So I could name it this, which is still read as line AB. Or I could switch the 2 letters and call it line BA, either with the symbol or with the word. Now there is a third name, and I want to go back and show you the picture really quickly to explain this last and final name. I don't know if you noticed, but there are some lowercase letters here on my diagram next to the arrows of my 4 lines. These lowercase letters are not points because I do not see points next to them and they are not capitalized. These letters are here for naming purposes. So since the line that contains the points A and B has N at this end of its arrow, I can name this line AB line N. Now, when I choose to name it this way, the letter has to be given to me and I have to use the word line. I cannot use the symbol. Points can be what are called collinear points. These are points that lie on the same line. So let's take a look at our picture once again, and let's name 3 points that are collinear. The first 3 that I see are A and C and E. Now it's very important that you separate these capitalized letters as I have done, okay? I've chosen to put commas between A and C, use the and symbol between C and E. I'm showing that all 3 of these are on this same line, line S, okay? These are not the only collinear points. If you were thinking E, D, and B, you are also correct. Those are collinear points on line P. It is very important that you separate them. If we were to write them like this, we're going to see in just a moment that when I write 3 capitalized letters close together like this, I'm naming another part of geometry. Now let's go ahead and look at our picture and let's name 3 points that are not collinear, or what we call non-collinear. Now to be non-collinear, we want to think in a triangular shape. So two of the points, like let's take a look at points E and C, they could be on the same line. Line S in this case. But then all I have to do is pick one other point, like D, to create the not collinear or the non-collinear. So E, C, and D, they make a triangle. E, A, and B, they also make a triangle. C and D and B, they make a triangle. Okay, so 2 are good. Any 2 points that are collinear are fine. To make it non-collinear, we just need a point that is not on the same line as the first 2. Perfect. Our next geometric vocabulary word is a plane. A plane has 2 dimensions, which is length and width, and it extends without end. It has no edges. It is normally represented by a shape that looks like a parallelogram, just like this. You'll see multiple points on it. You could see a line drawn on there as well. Imagine if you could. We would connect those 2 points together to create this line. Or it could just be this simple. To name through any 2 points that are not on the same line, there is exactly one plane. You use 3 points not on the same line to name the plane. So just like with non-collinear, you want those 3 points to create a triangle. So if you need to help yourself remember, draw yourself a little triangle with your points. Let's go ahead and take a look at our plane up above. I see 3 points and 3 points only, so I can use them to name this plane. A, B, C. There's a name. But Miss, I was thinking B, C, A. Yes, that is another correct name. But I was thinking C, A, B. Yes, that is another correct name. But wait, I was thinking B, A, C. Yes, that is another correct name. I could take all of those names and put them backwards, rearrange them, and I would have more names for this plane. A plane can have a lot of different names. It just depends on how you put the letters together. All of them are correct. All right, there is one other name for this plane, and that is using this capital letter M that is in the corner of my plane. Notice this capital letter M does not have a point with it. This is why in any of the names that I mentioned, I did not use the letter M. It's not a point. So it cannot be used in naming purposes with the points A, B, or C. However, I can use it as a name when I use the word plane. I have to write it out, and the letter M. Okay. These are not always given to you, but normally when this happens, it is for naming purposes, and the letter shows up in one of the 4 corners. Okay, it's never just hiding out here in the middle of the plane. That would just be silly. It's normally in one of the 4 corners. Okay, and normally you're going to see the point letters at one part of the alphabet, and this letter that's for naming purposes, it'll jump to another part of the alphabet. So we started at the beginning of the alphabet, A, B, C, and then we jumped to the middle of the alphabet, M. Naming purposes only. All right, just like points can be collinear, points can also be coplanar. Coplanar points are points that lie on the same plane. We also have what are called skew lines. Skew lines are 2 or more lines that do not intersect. They do not intersect. They never touch each other. And they are not parallel, because if you recall, normally when 2 lines do not intersect, it means that they are parallel. We'll talk about more about that later. What makes skew lines different and why they are not parallel is because they do not lie in the same plane. That is very important. They do not lie in the same plane. So let's just go ahead and underline that. All right, let's go ahead and draw and label 3 coplanar lines. I've already provided you with the plane. Now we're going to go ahead and we're going to create 3 coplanar lines. Oh, excuse me. All right, you can draw 3 lines any way you'd like. I'm going to go ahead and make mine intersect each other. They do not have to be coplanar, but no. Hold on a second. I don't like the look of that. Let me change it here. Okay, let me go up towards the top. There we go. And then let me swoop this way. It really doesn't matter. As long as there are 3 like it asks, you're fine. I'm going to go ahead and add the points of intersection. And then I could go ahead and put some letters in there, my A, my B, my C. So now we could actually name the lines and we can name the plane. 3 coplanar lines. Let's go ahead and look around the classroom and let's describe the location of 2 skew lines. So I'm going to do that by drawing the classroom, which is more or less a rectangular prism or something like a Kleenex box. Okay, let's pretend that this wall right here is the front of the classroom where the board is. This wall here is the one in the back of the room. This is the wall with the windows on it. And this is the wall where the door is that you came in today. Okay. Of course, this down here is the floor and this is the ceiling. Okay. So now that you visualized it, where would our skew lines be? Well, right here where the front wall and the ceiling intersect, and back here where the back wall and the wall with the windows intersect. Those 2 lines would be skew lines because they would never actually touch each other. I know it seems like maybe they would, but the walls with the window and the door are keeping them apart from one another. All right. We have 2 more basics of geometry to go over, and then we will be done with today's lesson. We do have what is called a ray. Ray AB consists of the end point A and all the points on line AB that lie on the same side of A as B does. Okay, let's go ahead and actually sketch ray AB. So a ray starts with an end point, so it has a point, and then it goes off in one direction and one direction only. So you're going to see it look much like this. Somewhere down near that arrow is going to be a second point, and this second point is for naming purposes. Because we want to call this ray AB, the first point or the end point needs to be labeled with the letter A, and then the second point would be labeled with the letter B. I can write the name of this ray just like I have right here for you, ray AB, or I can use the symbol a solid, a horizontal line with a arrow on one end. Now we have all decided, us geometry teachers around the world and for many, many ages, that the arrow must go to the right side of the name above the second letter, and it must point in that direction every single time. We don't ever want to flip it around and make it point the other way because then we just get confused. Okay? We always start on the name of our ray with our end point. Okay? Let's go ahead and sketch ray BA. Well, if I keep my points in the same position, right? There's my 2 points. And if I keep B here and I keep A there, then that means the ray goes in this direction. Now I know my rays look totally different from each other, but to name this ray, I would still call it ray BA because B is the end point. And so I have to start the name with the letter B. If I were to use the symbols to name this, I would put the letter B first, then the letter A. I would put my horizontal dash and I would put my arrow over the letter A because this is the proper ray for the arrow. I know it confuses your brain because the symbol for the word ray looks different than what the ray's picture does. But it is important that you use the symbol every time when naming a ray. The only way around it is to use the word instead. So the only way around it is to call it ray BA. All right, let's take a look at this geometric figure and let's name it. Well, I know I have to use the letters F and G because those are the two letters that are on it. It has an arrow, but only one. So this means it is a ray. I'm going to use this symbol instead of the word ray. And I just learned that I have to put the end point first, which would be G, and then I put the letter F. I want you to also notice that F, the point F, is the closest point to the arrow. Notice the point F is the closest point to the arrow. So they must be together in the naming as well. We are going to go ahead and take a look at what are called opposite rays. If we have a ray called CA and a ray called CB, they are considered to be what are called opposite rays if C lies on, that should say line AB. Give me just a sec here, guys. There we go. On line AB, between A and B, opposite rays are always going to be collinear. Take a look at my diagram down below. The 3 points that I'm going to make, ray CA and ray CB, are already all drawn on the same line. Because C has to lie on line AB between A and B, that means this center point has to be the letter C. It has to be point C. I'm going to put point A to one side and point B to the other. No, it doesn't matter. I could have switched them very easily. Here is ray CA. It goes in this direction. And here is ray CB. It goes in that direction. But together they make up line AB. All right, one last geometric figure that we need to talk about, and that is a line segment. Line segment AB or BA consists of endpoints A and B and all the points on line AB that lie between A and B. A line segment is very much like a ray. It is going to have start with an endpoint, but it is, instead of continuing in one direction, it ends with another endpoint. So here is point A, here is point B, and this is segment AB. I can name it by calling it line segment AB and writing out the words line segment AB, or I can use this vocabulary. I can use this symbol. Put the letters AB and then use the horizontal dash. I do not use any arrows at all because the figure doesn't have them. Some teachers might have you add the points. I don't particularly like to add the points because sometimes it's tricky to see, are you doing a point or are you quickly trying to do an arrow? Okay, so I would just completely leave them off. All right, let's take a look at the next one. Let's draw and label BA. Now I know what you're thinking. Let's switch up the points, right? Let's switch up the points. This one's B and this one's A. Sure, you could do that. You sure could. But do you have to? No. Just like in the ray, we could very easily erase these and keep the points A and B exactly where they were in our last example. I can name this segment BA because it doesn't matter which endpoint is first. I just follow from A to B, or I follow from B to A. Now, it would not have been wrong as well to label it, name it, and draw it and label it like this. Okay? All right, before we leave today, I want to just talk about congruent line segments. These are two or more line segments that have with an equal measure. They are exactly the same. There are many ways in geometry that we will talk about congruence throughout the year. It's a big concept in geometry. Okay? And we're just going to touch on this first one. We use markers to indicate that segments are equal in a geometric figure or a shape. If a diagram has more than one set of congruent segments, then you use more than one set of markers. So let's take a look at this figure right here. We can see that they are showing us that AB and CD are congruent, and they're showing that by putting two tick marks or the markers. We also can see that AD and BC are congruent because they each have one marker or one tick mark. Let's go ahead and end our lesson today by drawing and labeling two congruent line segments. We'll use our markers to show congruency. So we're going to draw our two line segments. 1, 2. We're going to go ahead and put our letters for our points. You can use whatever 4 letters you'd like. And now we're going to go ahead and use our markers to show that segment AB and segment CD are in fact congruent, equal in length and shape. That's what the congruence is doing. It's not just saying they're equal length, it's saying they're also an equal shape, which is very important in geometry. To show that though, I just have to put one little tick mark, one little marker to show that they're congruent. How do I write a sentence that says segment AB and segment CD are congruent? That's a lot of words to write. Well, we came up with this mathematical sentence. You already know how to write segment AB, and you already know how to write segment CD. We learned that today. The symbol for congruence looks like the equal sign because they're equal, but because they're more than just equal. They're not just equal shapes, they're also equal length. They're equal in every single way. We put a little squiggle mark above. And this statement reads, segment AB is congruent to segment CD.